Hello everyone, my name is Timothy Lee Grant, and today we are going to be doing another LeetCode problem. Alright, fun for everyone. So I'll minimize myself, and today we are going to be doing a medium. Let's do a medium. Alright, so as always, we are focusing on depth first search, so my idea is keep doing depth first search, focus on this one topic, get good at it, try to be able to get to the point where I can easily solve a medium problem. Then once I get to that point, okay, cool, then I can move on to another problem or another problem type. But first get good at one thing. That way I'm not just randomly doing stuff. Okay, so let us get started. So let's randomize it. And then we're going to pick the closest medium, which looks like it's this possible bipartition. Okay, let's see if we can do it. Let's see. All right, 886, possible bipartition. We want to split a group of n people labeled 1 through n into two groups of any size. Each person may dislike some other people, and they should not go into the same group. Given the integer n and the array dislikes, where dislikes of I equals A of I, B of I, indicate that the person labeled A of I does not like the person labeled B of I. Return true if all it's possible to split everyone into two groups this way. Alright, so I'm given this list of people. There's n people, and each person is, I'm trying to split this group into two separate groups. But the problem is, okay, there are certain people that don't like other people. So I need to figure out a way to get the people who don't like each other to not be in the group with each other. So, okay. I'm also given a list of list indicating the connections, and I think that might be actually a keyword, connections. So I'm trying to figure out, because immediately upon inspection this does not look necessarily like a depth first search. It doesn't look like a graph, and I'm trying to understand, okay, how might this fit in to the depth first search or graph traversal? So here I can think of these as kind of like an adjacency list. Okay, so node 1 and node 2 are connected. Node 1 and node 3 are connected. Node 2 and 4 are connected. Okay. But this connection is like an anti-connection, meaning that they don't want these people together. So, hold on a second. If they are connected, I'm trying to flip things around and try to think about, okay, well, what does it mean if they are connected? Because possibly I can say, like, if all of them are connected, then I can return false, right? Because there's no way to, I'm thinking if 1 and 2 and 1 and 3 and 1, let's pretend that's a 1, and 4 are connected, that's like a node in the middle connected to all of them. So it's one graph, and it means that, wait, no, that's not true. I can just put 1 in the separate group and then have 2, 3, 4. is it possibly that I'm looking for a cycle where like uh 1 and 2 are connected, and then 1 and 3 are connected, and then uh let's see, uh 1 and 4 are connected, so they're all connected to 1, but then also 2 and 3 are connected. So in that case, would it be the situation in which we return false? I'm trying. Um, so as of right now, I have no idea. I'm not sure if that's even true. It sounds like it could be true. Like it sounds like a possible avenue forward with this problem. The problem, or the issue that I'm having though is especially if it does work, I should have like a clear understanding of why, because I don't know if that's actually, I'm just guessing like, oh, it sounds like it might. So I'm, there's nothing to like visualize things. So if I have a node here, a node here, and a node here, they're all connected. That's one cycle. Can I partition this into 2? So I can have this one by itself. Bam. But then these 2 are still going to be together. So they would be in a group that doesn't like each other. So that checks out. And then likewise, if I cut this one off down here, well then these 2 up here are going to be in a group and they don't like each other. So I think actually this does work, that you can't have like a cycle. Okay, I'm gonna try coding this up, and then if it works, we have a lot of things. We still have a lot of work to do because we need to understand why. So let's just see if it does work. So the first question now I need to figure out is like, okay, cool. I know what I'm trying to do. How do I actually do it? How do I find a cycle in a graph? I haven't thought about that before. Well, if I start at a node, or if I start at a location, I can traverse to the next location using like the adjacency. And if I ever get to the same node again, I know that I have a cycle. So I'll have something like visited is a set. So initially it's an empty set. Okay. Then, okay, I also need to figure out like, how do I actually traverse an adjacency list, because normally I do like traversing through recursively on a on like a tree. Would it help if I turn this into, what's it called, like an adjacency matrix or something? Would that help me? Well, I have to say this is a really good problem, because it is introducing to me a lot of concepts which I am shaky about. So thank you to number 886. You have shown me, I'm actually here in this problem going to create some notes, and then I can come back to this. So things to study, and this is going to be let's see, what do we need to study? So first is how to determine cycles in graphs. Okay. Second thing to study is how to traverse an adjacency list. Likewise, how to traverse an adjacency matrix, because I don't know how to do either one of those. Let's see, what else do I need to do? I feel like there's more, but okay, so this is definitely what I need to do. How to determine if cycles in graph, and implications of a cycle. So I just kind of think about what are the implications? Like, what does it actually mean to have a cycle? Obviously, I understand like a cycle means you come back to the same thing. But what does that actually mean? What are the implications? What would that, like, having a cycle should trigger something in my brain. Obviously, I know that I can't just do a pure depth first search and not take into consideration if there's a cycle, because then I will never escape that. So I understand that, but like there has to be, that's I believe pretty easy to fix. You can just put a if in visited or something like that. You can put some like blocker in your code. But that's not what I'm quite meaning. What I mean by the implications is like, what useful information does it give me that there is a cycle or there is not a cycle? Like, there has to be some kind of useful information that tells, that gives me insight into the data itself. Okay, so like right now I'm trying to find like, okay, does having a cycle, does that give me information on this possible bipartition? I don't know. It feels possibly like it. I went through a three 2 nodes here and 1 node here, a three-way example, and it seemed to work. But does it scale to like 10,000 nodes? I'm not sure. So anyways, okay. I said that I want to try to figure out how to traverse this adjacency list. Let's see. So if I'm doing a depth first search, I'm gonna start. And the other thing that I'm seeing is it doesn't matter if it's 1 2 or 2 1. So the order doesn't matter. So I forgot what that was called. It was like non-directed, I think it was called, something like that, meaning the connection goes both ways. How am I gonna do this? How am I going to do this? So what if I just like iterate through each of the elements in I don't know if this is gonna work, but what if I do something like this? I have a my elements equals a list, and now for element in dislikes. Okay, and now I actually want to initialize this with like -1. Okay, -1 for in range length of, no, I just need n. So I put -1 in all of the values of this, or maybe I can just do none, like that. And now I'm going to add like I'm going to get dislike, and dislike is going to be element. So connection 1 connection 2 equals element. So like for example, I'll get this, and connection 1 is 1 and connection 2 is 2, and now I'm going to like index this my element at connection 1, and that is going to be equal to connection 2 my element connection 2 equals connection 1. I have no idea what I'm doing right now. I'm trying to figure out how to actually navigate through these elements. So essentially what I'm trying to do is get to the point where I can start at like node 1, and then I need some way to determine node 1 and all of its connections, because I need to add, the way that depth first search is, I need to add um, all of the connections onto the stack from node 1. Then I need to pop from the back of the stack, and that will be another node. Like that's going to be a connection. And that's kind of what I'm trying to do here. So essentially it should be something kind of like this. Like for the first index, I'm going to have all of the connections which node 1 is connected to. As of right now, node 1 has none. So do I actually want it something kind of like this? Like an empty list? Kind of like that? So as of right now, it's like this. Like, and then here's, let's just say that we have 3, n equals 3. Something like this. So I should have 3 indexes, and I want to fill up each index with the associated like connection or node that it's that particular element is connected to. So in node 1, I want to fill up well, this has 4. Okay, fine. Let's just do 4. There. So for this one, I want to fill up that node 1 is connected to node 2 and to node 3. So I want something like this, like 2 and 3 in here. Then for node 2, I want it is connected to node 1. Node 3 is connected to node 1. So like that. And then node 4 is connected to node 2, right? So node 2, and node 2 is also connected to node 4. So something like that. And then what I'm planning on doing is being like, okay, cool, I have this list here. Now I can visit the first element and add all of that to the stack. Its stack. I can add 2 to the stack and add 3 to the stack. Then I pop from the back of the stack. So, okay, I see 3 here, so I go to 3. Okay, well, this is actually 1 indexed, so 3 would be here. So now I see 1 is on the stack, but 1 is already visited. Oof. Is that going to cause... that's going to cause a false positive on the cycle. What if I just say like, hey, I know that the connection actually is two ways, but let's just make it one way. Let me this is okay, this is a two-way connection. Let me just see if this would work. So I'm going to have a list. In that there's going to be one list, two list, three list, four lists. Okay. Now I'm going to say one is connected to let's see. The zeroth index is, or the, yeah, so one is connected to this one itself and two. So this is going to have two in it, right? And three. And three. Okay, and then this one, it's going to come here and say 2 is connected to 4. So 2 is connected to 4. And then I'm not going to add that 4 is connected to 2. So I'm essentially just going to say that the first element that is in there is connected one way to the second element. So I'm going to say like let's see, the first element is connected to the second element, but not the second element is connected to the first. So it's a one-way connection. And then if I see any cycles, then I return false. So like for this one, it would be, so this one, it would be, there's 3 in here. So 1, 2, 3, and we are going to do 1 is connected to 2 and 3, and now 2 is connected to 3, and we can see that, okay, we're getting back to 3, so there is a cycle. So we see 3 twice in here, and we return false. So, I mean, like, in each of the examples, it is working, but I don't know like why or if it expands beyond just these test cases, or kind of like the very vague idea that I have in my head. So let's keep going along this path because we're definitely learning a lot of fun stuff, but we need to be cognizant of, even if we do solve the problem, it's not we can't leave it there. Okay, so anyways, I am going to comment these ones out. So okay. Anyways, there we go. So okay. So I connected those together, right? And then what do I want to do? So I'm gonna, okay. Now I want to go through each of those elements. So for element in my element, just gonna make that a s. Okay. Now what do I want to do? I want to add. Okay, so I want to add that particular element to my visited set. So if element in visited return false, else visited dot add and then element, okay, and then return true. I have no idea if this is gonna work. I'm just gonna run it. I don't know. I don't know. What? Wait, what? Why? Unhashable. Okay, so visit if element in visited. Unhashable type list. Okay, so um oh, okay, so I'm gonna go through the first node, but I need to go through all of its connections. So for connections, for connection in element, okay, then I do this, and then element actually is like a connection node, something like that. Int is not iterable. I thought you just said the element was a okay. I'm almost out of coffee as well. Okay, so let me let me think about this for a second. So, um, for element in elements. Okay, so what is element? Element is going to be um element is going to be like that right here, right? Like this represents element. So let's see. 2 and 3. So is it a list, right? Which would be iterable. Um, int is not iterable. Element should be a list, right? So, it was on this line that it failed, right? Yeah. Come on. So, it's first going to be an empty list, so it's a list of lists, and I'm creating n of them. So, I guess, well, first off, like, what should I do blocking? Like, if n equals 0, then return true. So this guarantees, once I hit this point here, this guarantees that I do have a list. Okay. I have at least one element in here. And then I'm going to create a list of lists with each element is a list, right? So, okay, cool. Now, in that list, I am going to store. So let's say I have 5 lists, okay? Now I go to index, oh wait, hold on a second. I go to index connection is actually, these are, I noticed that these are actually, like, 1 corresponds to, like, the first index, but it's 0 indexed, right? So 1 corresponds to the first element. There we go. That's the correct vocabulary. So I need to just subtract 1 to each of those. So anyways, now, let's see. I take this. Oh, don't I want to append to this list? So it should be It should be something like this. So my elements index and connection 1 minus 1 dot append, and then connection 2 minus 1. I think it should be like that. So now I am appending. What am I appending? I'm appending a list, or I'm appending an integer into a list of lists. Okay. Is this? No. No. Why? What? Why? Why? You know what I'm gonna do? People say that this is a horrible debugging method. I don't care. I don't care. It's great. I don't know why people say printing is bad. Connection, and then print element. Okay, cool. You are going to reveal your secrets to me. So element. So connection is 1, right? Connection is 1. Okay. Element is not visited. This is a connection, right? Like, for if, wait, hold on. If, connection, is that right? If a connection in visited, that. Visited.add, and then I want connection because it's the element that I'm looking at. Oh, okay, yeah, okay. I went on a wild goose chase there for anyways, let's submit it, see if it works, and then we still have that wrong answer. Great, good, perfect. Well, what do you say? I think we kind of just I think we have to look at GPT for this one because I have no idea what I'm doing. I have no idea if I'm on the right track, but we do need to see if... Okay, so... let's go to here. So this is my code for here. I am wondering if I am on the right track. Okay, let's see. You're definitely on the right track with thinking about how to approach the problem of possible bipartition using graph traversal techniques. However, the current implementation has some areas that need improvement to correctly address the problem. Okay. Key points to consider. Your approach to building the adjacency list elements is correct, okay? Detection or cycle detection and bipartition logic. The problem requires checking if the graph can be colored using 2 colors such that no adjacent node have the same color. Okay, wait, hold on. This is actually a different, seems like a different problem, but the same, same idea. I think that they took the problem and just changed this one is like friends who hate each other, and the other one is colors that don't want to be next to each other. So I think that maybe they're similar. Okay, so using breadth first search or depth first search to ensure that the graph can be colored correctly. Yeah, And it also says like, okay, cycle detection. So I think I was on the right track about cycles being important here. First off, before I actually go and try to investigate this, let me just see if this works. Because I don't want to spend a lot of time on something, like investigating something, and then it doesn't even work. So let me see about this. Okay, so it does work. Therefore, we do know that that was the correct solution. So now it's time to investigate, like, why? What's going on? Okay, possible bipartitions. Self and in dislikes, list of list, returns a boolean. Yeah. So adjacency list, creating a empty list for, so I did this. So they are appending both. So this right here is them appending to both elements. So it is a two-way graph. I said, well, maybe I just make it a one-way graph. They're making it a two-way graph. Let's see. Array. So to store color of each node. Again, this is like not color, but it's okay. Anyways, store color of each node. So, what would the analogous situation be to the friends? I think that that would just be like the friend index, right? Yeah, I think so. So, breadth first search. They use breadth first search. They're, both are okay because you're just doing a different traversal of a graph. So they use Q. We would have used stack if we wanted depth first search. So anyways, start coloring with 0. So color start equals 0. And so you're going to be traversing through all of the graphs, or all of the nodes. Okay. So we're getting the next node, great. So for neighbor in adjacency list. So now we're taking all of the connected nodes. That's kind of the path that I was going on. If color neighbor equals -1, the neighbor has not been colored. Okay, color with the opposite color. Okay. So opposite color. I think that there can maybe only be two colors or something. Oh, this is like the group. Let's say group 1 is purple, group 2 is green. So you have these two groups. Okay, that makes sense. So we're just saying set it in the other group. So if they don't like each other, set them in the other group. Okay, LF, and then -1 means they haven't been put into a group yet. I see. Okay, so LF, color of neighbor equals, so if there's a conflict, then we return false, otherwise we return true. So then what's going on here? So we go through each of the people and we check if, so we first say, hey, you are, let's see, if, no. So if the node has not been colored, if not, breadth first search. So we just find a node, a friend. Breadth first search. So we are going through. For I in range of n, if color I equals -1, so if this returns false, it gets passed up into here, and then I check. Okay, so it's just like grabbing the result of here. So if there is a false, um, if one of those colors can't be put into either group, then you return false and the function is wrong. Okay, so moving forward, I am going to have to, it deleted my, wait, hold on. I can do like submissions, right? Submissions, wrong answer, put this in here. Okay, cool, okay, cool. So, I am going to have to look into these things to study it, try to figure out what each of those points are, how to do it, and try to get good at it. And then the part that I don't want to do, but I have to do, is we have to return to this problem. So we were unable to solve it. I was unable to solve it. You guys might be able to, probably can, but I wasn't. So in a few days, or maybe tomorrow, I will need to put this in, or I will need to attempt to solve this problem again and make my put this into my memory. So yeah, anyways, thank you guys so much for watching this video. If these kind of LeetCode videos are interesting to you, or you like the video, consider subscribing. That would be awesome. And I will see you guys tomorrow with more LeetCoding videos. Actually, I'm planning. It's only 1 o'clock right now. I'm planning on making more LeetCoding videos today. Because there's a fair amount of a fair amount of problems that I've actually failed in the past, and I need to go revisit them. So I need to pull those out of my backlog and start working on them. Then the other thing that I need to do is I'm going to continue learning Java, because I don't know Java, and I'm going to be doing JavaScript. So there's a lot of things coming up. If you enjoy that, subscribe, and I hope you guys have a wonderful day. My name is Timothy Lee Grant, and I will see you soon.